Do you have a Nintendo Switch that doesn't charge or power on? Well, I'm Jesse from VCC Board Repairs, and in today's video, I'm going to walk you through how to diagnose the issue and how to repair it. Now, please note, this is a more advanced repair, so I don't recommend you try this unless you have some experience soldering. So just stay tuned and we'll walk you through that whole process. All right, so here we are at the workbench. So one of the first things you want to do when diagnosing is to hit that like button for the YouTube algorithm. That really helps us out here in the channel, and it costs you nothing to do. So just a little friendly reminder, but I'm just joking. You don't actually have to do that to diagnose. But the first thing you do want to do when diagnosing is to get a USB meter and plug it in and see what is the USB charging current. So let's go take a look at that right now. So here I have a USB-C meter. It's plugged into a USB-C cable to a USB-C charging brick, and you'll see there's nothing on the display. This is one of the steps of diagnosing that you can see nothing happens. So could be the port is physically damaged. It could be a short. Let's take a look afterwards. But you'll see next is this is a USB-C cable plugged into a 5-volt, like a regular charging brick. And you'll see here on the screen is my USB meter for this one. So if I plug it in, you'll see a 0.1 USB current draw. So if I turn on the chart, you can see if I unplug it, it drops to 0. And I'm talking about the green number. This is the current. This is the important number. Now plug in the charger, and it only goes up to 0.1. This is a really low charging current. At the end, you'll see when it's working, you get a much higher reading. So it's always good to compare, what happens before and after, so you know if you made progress. So no matter what, we get the same reading. So let's go ahead. The next step is to actually do a visual inspection of the board, especially the switches. They're super easy to damage the port, especially with kids. So let's take a look. All right, so one of the things is when you want to look at this under a microscope, there's not enough room under your scope to look at it. So the trick is to pull your scope over the edge of your bench. That way you can go here over the ledge and get a better look. So let's do a visual inspection. Now these ports get damaged pretty easy, and it's the most common reason why these stop charging. So if you can look, might be a little too dark to look. Let me extend this a little further. So just by lifting your Nintendo Switch higher and lower, you could also just focus it. But I actually see a damaged pin here. Right here. You see that? That shouldn't be there. It should look more like the bottom one. Actually, it's on this angle is the top side. All the pins should be flat. You see here, there's one pin that's sticking out. So the port is definitely damaged. Also, when a port is physically damaged like this, sometimes the pins can short within each other and damage a chip. So let's check for shorts on the board as well. First thing you want to do is set your multimeter to diode mode. The little triangle here pointing to the right with the little line across it. Check your user manual or Google it. But so the way diode mode works is the red and black probe. If they touch together, you'll hear, at least on my meter, it beeps when it has continuity. So basically a 0.00 reading, and then OL when they're not touching. So this means it's shorted or has continuity. And the way you do diode mode is you put the red probe on ground, so something metal like the shield, and then you just probe around the chip that's in question. So in this case, we have the N92 chip. This is super common to short out. And we're gonna probe around for shorts. So red on ground. And then what you wanna look for is put the probe on one side. I'll get 330. And let me adjust that. So one side I get 0.330, the other one ground. Now capacitors, that is normal. Reading, ground. So the actual reading itself doesn't necessarily matter right now. It's just we're looking for shorts. So those are good. There's some components that are like resistors or filters that get a reading on both sides. So be aware of that as well. What we want to look for is something that reads short on both sides of the component. So if you get a reading, you can just assume the other side is good for now. All right, so we get 345 ground. This one we get 0.001 and 0.000. So you'll see both sides are essentially reading as ground. That means this capacitor is shorted, or whatever is connected to is shorted. And look at that, 0.002, 0.000. So this one's also shorted. So same thing, either the capacitor or the chip is shorted. In these scenarios, I've seen almost every case be the chip itself, although I have seen a capacitor be shorted as well. We won't know until I pull the chip and then measure these again to see if the short was cleared. If I remove the chip, the short is cleared, then that, by deductive reasoning, you could assume this was the cause of the short. So then we'll replace it, measure again, and if there's no longer a short, then that proves the chip itself was the issue and is solved. So you can just keep probing around. You can just jump through. Usually it's the bigger caps that fail, so I'm just doing this for illustration purposes. I normally just check these big caps here, and the most common ones are right here. Yeah, so short reading of 0.330. So yeah, there's definitely a short here somewhere, either a chip or these caps. We won't know until later. Now the next component you want to check for is this. Same concept, right? Ground and some reading. Some reading and ground. Ground, some reading. So you kind of just hop around, look for something that's shorted on both sides. That gives ground on both sides, like you just saw in the last example. But this looks good. So I would say this is good. And then lastly is this P13 chip that's here on the back. This one also gets shorted sometimes as well. So what you do is red probe on ground, which is this charging port. And then just probe the big cap. Nothing. You can probe the rest, but usually if this cap is shorted, then maybe the chip itself. But yeah, I'm not detecting any shorts. My understanding is this chip is responsible for docking. So if you put this in a dock and it doesn't work, then maybe it's related to some issue here. But yeah, this is fine. All right, so as you saw, the main issue is going to be an M92. So the next step would be to remove the port, just because it's already physically damaged. Let's get that out of the way. And also remove M92 to see if that short clears. As you saw, I probed around BQ, there was no issues. Probed around the P13 chip, there's no issues. So definitely something to do with that M92 chip. So let's go ahead and get that removed. So here I have the switch mounted on this tool jig. It has little adjustable clamps to hold the board down. And you can see the charging port is here, M92 is here, and it's holding it pretty steady. So let's go under the microscope. All right, so let's start off with the charging port. So one thing we can do is there's a liquid damage indicator sticker here. Let's save this for later. I'll put it off here to the side. All right. So to remove the port, what you got to do is add some flux. I use Amtech. Currently I'm testing out this new 560 Amtech, and it works pretty good. I normally use 559, but it doesn't matter. Any Amtech should be good. Now I do use low melt solder wire. This is 138 temperature, which makes it a lot easier to get this port off. So I'm just going to flood the anchors with this low melt solder. I'm going to, the goal is to replace the original factory solder with the lower melt. It makes it a lot easier to solder with. It basically brings down the overall melting point of the solder when you mix in low melt with the factory, high temp melt solder. So, the easiest way to get the port removed is to just flood it with this solder, because we're going to pull this off, so it doesn't really matter. All right, so I think I got all the spots I needed. All right. Next is my hot air station. I'm going to set it to pretty much the highest settings. So let's start off at 450 Celsius, 120 air. See how that goes for us. All right, here's the port. Basically just go in circles. When you go in circles, what you do is you're trying to evenly distribute the heat. So your goal is to have all the solder melts at the same time. You don't want just one corner to be melted and the other not. That's how you rip pads. So, and one thing that I don't know is if there's actually rip pads underneath. So let's see what happens. So using my tweezers, I'm gently pushing up to see if the charging port comes loose. You see it has some wiggle to it, so it is coming off. There it goes. Alright, it's off. Thankfully, there is no rip pads underneath. A lot of times these pads down here also rip. Alright, so adding some more flux. And what I'm going to do is wick away the existing solder. So as you saw, I got a bunch of extra solder on there. So using these art of repair reverse tweezers, I'm going to holding a piece of wick and kind of rubbing this solder wick, kind of absorb all that extra solder. Now I'm not going to get everything. I do need some more wick here. You can see this whole piece of wick is just absorbed the whole thing. So let me get some more solder wick. Alright, so one trick here is always add flux when soldering, otherwise it doesn't, your soldering doesn't happen. So I'm going to try with my iron. Alright, so that sucked up all that. Alright, so once the wick stops sucking up, stops sucking up that much solder, just clip off the excess and kind of create a new solder wick. Now, by the way, I will link to all my tools in the description in case you're missing one of these tools, or you want to get started with these type of repairs. Now, like I mentioned, you don't want to do your first repair on a customer's device. If it's your own device, that if you try it and you damage it, then all you lose is that device. If you try it on a customer's, you could risk a lot more, like an angry customer, bad review, and that's not good for you. So definitely don't practice on customers' devices. Practice on your own stuff, and then graduate to customers' devices. So, all right. So there's some solder still here in the anchor holes. So I'm gonna use hot air, try to absorb it. So you want to clear out these anchors with solder, otherwise the replacement port won't fit. All right, so there you have it. It's pretty much clean. Toothbrush and isopropyl alcohol. You want to clean up this area, clean up all that old flux. We're using a little towel here. We're going to try to absorb all this stuff. All right, so we got the port removed. Physically, you can see the pads are clean. The anchor holes are pretty much clear. Now let's, just curious. So I'm going to go back to diode mode. I'm just going to double check. Are these caps still shorted? Yep, 0.002, 001. So definitely it wasn't the port, but the port could have been the original cause to blow the, blow something on the circuit. So to remove M92, basically same concept. Now you got to add flux around the chip. And then what I'm going to do, I'm going to first start off with some low melts as well. Although it's kind of tricky because there's not much room to fit your iron. Let's see. Be careful. If you're new to soldering, you might get a blob of solder on the surrounding components. Goal here is to get solder on the chip, these pads that wrap around the chip. Put some solder in my iron, and then oh, there you go. I got some solder blob on this component, so I'll show you how to take that off. Pretty much same process as cleaning the charging ports anchors. Is use some wick. So the wick is basically braided wire, which likes to absorb solder. So just kind of place it nearby, put your iron. It was so quick, you guys couldn't even see it. So basically your iron touches the wick touches the solder, and it just absorbs it. All right, so I basically tinned the pads with the low melt. It should make it a little easier to remove. Let's go back to my hot air. Let's try 400 Celsius and 80 air. So in circles. All right, so a piece of solder right there. All right, you can see the pads that are super shiny right now. Most likely the solder is molten, but the chip is still physically in place. Also, one thing to note, you see the dot right here? It points to this arrow. So when you replace it, this dot has to be in this corner. Now on iPhones, the chip has a dot, but the board does not show any arrows. So iPhones, you have to take note of which corner that dot goes to. Otherwise, you can kill the board if you put it the wrong way. And it's still on there. Now you don't want to pull the chip, like yank it. You want to just wiggle it. If it doesn't move, then it definitely not ready yet. Can also just bump it to see if it moves. Yeah, see now it moves. So now you see it move. So now I could just lift it out of the way. Alright, so before I start measuring, I'm going to add some more flux. Going to come and wick away all that solder. You want to do this while the board is still hot. If you're going to use your iron to solder, to like wick away the solder, you want to make sure it's while the board is hot. Let it cool down, then it makes it a lot harder for the solder on the pads to melt, and that's where you start ripping pads. So definitely, if you never wicked before, it is something you have to practice and get a feel for. There you go. I blew away all the isopropyl alcohol in the flux. Now here comes the test again. So I'm back in diode mode. So red probe on ground. And yeah, there's the chip. You see how I get OL, but it's no longer shorted. So ground, OL. See how now we get a different result? So that means the diode mode reading, if you follow the little trace, it goes to the chip. So it means that short was on the chip, not on the cap. So yeah, that solves that short. So in theory, when we replace this chip and then the port, we should be have a working device. So let's go ahead and prep this for new M92. So what I'm going to do now is, this is my regular 183 solder. The, what is it, 63, 30 something, 63, 38, 37, I think. I don't know, I'll link all the tools in my description for this video. The goal here is to tin these pads with some solder, but I don't want the low melt, that seems to be a little too fragile. So I want the pads to be like about the even amount of solder on each pad. Now the middle pad is the ground pad, and that's basically what was holding the chip down at the end. So what I'm going to do is I'm going to hit this with some hot air. There's like a little spike of solder there. I want to flatten it out a little bit. So the way solder works is basically like a liquid. So surface tension kind of creates this effect. There you go. Yeah, ready to go. So let me clean this up. You don't want to use old solder for too long, because then it doesn't work that well. It gets in the way. So whenever possible, clean up. And then we'll put fresh new flux after. All right. Alright, so here's the new chip. We'll also link these in the description if you're looking to buy any. Let me get the port out as well. I'll put the port to the side. Alright, so one of the things here is, let's see, the part number is M92 T36. That's the right one. All right, so it goes like this. Remember that dot on the corner goes to the arrow. So add some flux here. Now one of the things is this chip doesn't come with any solder on the pads. Let me just tend them as well. Basically what I'm going to do is add my own solder, so it makes it a little easier in installing. So put a little piece of solder wire nearby because you will need it. So same concept we did to the pads, basically just prep the surface for soldering. Just oops. Alright, I don't know if you guys can see that, but there's like a blob of solder. That happens when there's not enough flux where you're soldering. So add some flux. And then run your iron over it really fast. There's one pad here in the corner that hasn't got any solder. There we go. Now on the center part, I don't like to add too much solder here. So that should be fine. Alright, so I basically got this chip prepped. I mean, it doesn't look the prettiest, but it doesn't matter as long as it works. Alright, so like I mentioned, gotta find the dots. One thing is on the bottom side, you'll also notice there's like a little notch. That's kind of the indicator as well. In case you can't see it from the top, you could always look at the bottom. Let me remove the solder wire. Alright, so try to, as far as installation, you kind of just want to eyeball it. Like try to see if you could picture it being in the center. There's no other way really. So what I'm going to do is I'm going to hold it with my tweezers, keep an eye on the pads and see when the solder starts melting. And slowly kind of let go and see if it goes into position. There we go, I've let go. Look at that. And if you notice that, but the chip kind of snapped into a position. If I push it, it kind of snaps back. That means the surface tension of the solder is kind of holding it in place. That's what we're looking for. Now, just to be sure, I'm going to add some more solder on each leg. Just to make sure all the solder pads are, making contact. You know what, let me use my micro pencil. That is has a smaller fine tip. Although the micro pencil, although it is smaller, it also can't transfer heat as well. So you do have to kind of balance those two. It's not as powerful as this, smaller iron tip. The goal here is to kind of just add some solder to each leg in hopes that it allows the solder pad to make contact with the chip. So one thing you can do is if you notice micro pencil isn't making the solder flow, you could use some hot air for assistance. Increases the temperature. So I think I got solder in all the pads. I'm gonna hit it with some hot air again. There's just one pad here that looks a little questionable. Add some solder, and this probably a ground pad. Ground pads tend to, there you go, tends to require a little more heat. Just because ground pads is basically the whole board is like a giant ground, so it sucks up all the heat and it spreads it out. I'm just gonna try to clean up here. I don't like to leave a bunch of flux around. All right, so let's see if we could get a glimpse here. All right, so those pads look good. That looks good. Now, if you're new to this, you might want to look closer and get a real good visual inspection. From what I can tell, this looks all good, so should be fine. All right, now for the charging port. Actually, before I go, the next step. All right, here's the moment of truth. Was this issue solved? So, look at that. It's not no longer giving a 0.000 or 001 reading. These are all giving, 300s, 400s. So there you go. This is solved. You could also probe the rest to make sure nothing changed. Yeah, we have all good readings, so should be fine there. Now we got to reinstall the port and finish up this repair. So one of the things you got to do is prep these pads. Only the pads, not the anchors. And then so what I'm going to do is I'm actually going to add low melt solder on the bottom row, because these are kind of like the hidden pins that you can't see if it's soldered on. So this adding low melt here kind of makes sure it melts and makes contact with the port. On the top row, I'll add regular 183 solder, which is fine because it's going to be hit with direct heat, so it should melt. All right. Now, one thing I like to do also is tin the pads of the port. So what I do is add some flux. This kind of ensures, kind of like the chip where you tin the pads. I also do it here so that the solder from here makes contact with the solder on the board and just makes things a lot easier. So basically just add little spikes of solder like this. Now this is something that does take practice to kind of the hang of, but essentially there's like a little blob of solder on your iron, and then you just apply it to the tip. It should kind of absorb some of that. Same thing here. Now this one's a little harder because there's some plastic, so be aware. Try not to burn the plastic that makes up the port. I think this should be fine. I think it should be good. The goal is really just to get some solder on the pins, some pre-solder, I guess. All right, so here's how you do it. This is my new replacement port. I'll put this in, I'll link these in the description as well. I'll put my hot air to, let's do 400 Celsius with 80 air. The goal here is to just get the pins soldered to the board. The anchors, they can be soldered manually later with the iron. You know, really the goal here is to get those inside row pins soldered on, because that's you know, that's really what does all the work, the charging, the data transfer. So you're just gonna hit it with hot air. I try to go at it from different angles. Use your tweezers to press down. You'll see the port does kind of move around, but the pins stay aligned. That's good. I'm just gonna maybe give it another 5-10 seconds. I think it should be good. Alright. Take a look at those pins right there at the top. Now the inside row is low melt, so it does take a lot longer to cool down and solidify. So let's just wait. I'm putting pressure with my tweezers, pressing down, because the top row is like one side of the port and the bottom row is the other side of the port. So sometimes the inside row doesn't make good contact. You'll plug in the charger and it will charge one way, but if you flip the charger over, it does not. That's because, you know, the inside row is not making good contact. Alright, so it's been some time. I'm going to drop some isopropyl alcohol. This also helps cool it down and give me an idea of how hot everything is too, because the sizzling for sure is like really hot, but it kind of just evaporates, then it could be cooled down. Alright, so I've let go. I'm blowing out all the alcohol. Now to be sure, I'm gonna check these pins here that are visible. Let's see how they look. Alright, so visually, they look good. I do see, it does look like every pad is making contact. You can use your blade to push them, push the legs, see if they move. And these all look good. So in theory, the inside row should also be good, but we can't see it. There's no way to know other than testing to see if it charges. So let's go take a look. Okay, so if you remember from earlier, we plugged it in, nothing happened. Now we get the screen here turns on and it shows some 15.2 volts with 0.01 amps. What matters is that this thing turns on and it's showing that it's working. Plug it in the opposite way. See, it turns on and it's showing 15.3 volts and 0 amps. So that doesn't really matter. Point is that it's charging. So let's finish up this port and, you know, solder the anchors and it should be ready to reassemble. Always add a lot of flux when you're soldering. If you don't have flux there, solder's not gonna flow how it should. So yeah, just put your iron. Keep in mind these are ground, so it does take a strong iron to do it. All right. I'm now going to use some heat up. I'm going to flow the solder so it looks better. I think that should be good. Yeah, the anchors don't really do anything other than provide strength to the port. So as people plug things in and out, you know, it won't break the port. They're just like the handles that grab onto the board. So yeah, it's pretty good enough. Now we're gonna go ahead and test, make sure everything's working. So if you remember, when we first started, I would plug this in and nothing would happen. Now I plug it in and I get this to pop on. It says 15.3 volts. So that's working. Flip it over and you'll see this will come on. In a few seconds, there it goes. And the battery icon comes on. But if you notice, I unplug it and it instantly turns off. That's actually a clue that the battery is not charged. Just give it a second. Comes on, unplug it, instantly shuts off. That means the battery is too dead to keep the display on. So I'm going to show you here how to measure the battery voltage. What you want to do is unplug the battery. And then we have the red and black wires here. And then you want to set your multimeter. And get this out of the way. So you're going to set your multimeter to voltage. There's AC and DC. AC is the squiggly line. DC is the one with the line with the 3 dashes. So you want volts in DC. And then you put the red and black on the corresponding wires. And we get 2.841. So that means this battery is too low. Most lithium ion batteries operate within like 3.2 to 4.2 volts. So you want to kind of boost this voltage up so that it's enough for the switch to recognize the battery and start charging it. So what can we do? So to boost this up, you have to manually charge the battery. Easiest way to do that is your DC power supply. Plug in multimeter probes. So like this. I have extension cables that run up to my DC power supply up here. So red and black, positive and negative. Do not use the ground, use the positive and negative. Set your DC power supply to like 4.3 volts. You want your current to be at least 1.5. So right now, 4.3 volts, 1.5. So I'm going to enable the output. And then you probe the red and black. And you'll see the DC power supply shows the current, the amps is at 8.850 something. So if you just hold this long enough, this will charge up the battery. So let's give it about 1 or 2 minutes, see what happens. Okay, so it's been about 2 minutes. You also see the current now lowers, like in the 600s. So let's take a look under the microscope. And then let's measure the battery voltage again and see where we are. Fortunately, this is a process we have to go through. All right, look at that. 3.195, basically 3.2. So I think it's at a good enough charge for the Nintendo to actually boot up and actually display something on the screen. So I'm going to plug in the battery, plug in the charger. All right, charger has came on. Now you see 15.2 volts and it's taking 0.17 amps via USB charging current. It's been a few minutes and you actually see it's turning on and it's charged up enough to power on the device. If you look at the USB meter, you'll see it's charging at 15 volts and it's pulling in 0.76 amps. That means it is charging perfectly. Now if I flip this over, you do want to test both sides and make sure that charges both directions. This confirms that the pins on both rows are soldered on. Now same thing. So 15 volts and 0.74 amps. Okay, so for good measure, we're gonna also test the original 5-volt charger, just so you guys can see the difference. So if you remember, early on it was saying 0.10 something. Now I plug it in, you'll see on the screen. Let me start the chart so you guys can see it in a chart. It is at 1.29, 1.3-ish amps that is charging. So 5 volts, 1.3 amps is 6.3 watts basically. Flip it over, you'll see exact same charging. It goes 1.3 amps. So this proves the charging port's fixed. The charging IC, the M92 chip, is also fixed. Everything's working. So we have successfully fixed this Nintendo Switch. Alright, so there we have it. The Nintendo Switch is now fixed and functional. So we found that the charging port was physically damaged by visually inspecting it, and then with Diode Mode we found that the M92 chip was shorted. So after that we got it all fixed and working, and now we can send it back to the client. So if you enjoyed this video, make sure you hit that like button and subscribe to the channel if you want to see more videos like this. Also, I will link below in the description all the different tools I used in this video, so you can also try to repair this as well. And if you need this repair, send us a message. I'll have those links in the description. And let me know what you thought about this video. It was pretty long, but I did walk you through every single step in diagnosing and repairing. So until next time, keep on soldering.